Well, hello all. I just wanted to record this video as a response to the question I put up in the community. I think it was August 4th that I posted. It says one day ago, but just wanted to go over the answer, give an explanation. Got a lot of good responses. Some were close, some were it could be and it could not be. Let's first see what the problem was. It says Whirlpool electric heat dryer. So I'm not going to get anybody, but you guys need to read the question because I did have one response that asked me whether it was gas or electric heat. And the very first four words of the question says it's electric heat dryer. I specifically wrote it in the question because the diagram that I'm showing you has both an electric heat dryer in the top and a gas and heat dryer. We're showing the gas burner here instead of electric heater on the bottom here. So I specifically said electric heat dryer so you would only pay attention to the upper half of the diagram. Service call says the first call does not start. So you go to the house and you find out that the thermal fuse is bad, and that's this thermal fuse right here, and we'll go into it in a minute. You got to call back. The second call, 2 days later, the customer says not working, and the thermal fuse is open again. So you replace the thermal fuse, test the dryer runs and heats, and you leave, and 2 days later you get another call. Thermal fuse has opened again. This is an actual problem that happened to me in the field. And there's just some of those things that just stick in your head you never forget. So before I go real deep into this, I do want you to watch this video I got from the Whirlpool's website. And that particular video is going to, let me see here, I can't get this screen to minimize, 1 second. Okay, and this video is made by Whirlpool here, and it's going to talk about the air circulation. And this is important to know so I can explain to you what parts are there for what purpose, because in order to troubleshoot you need to know what those parts are there for.
Optimum drying performance is achieved through good airflow because good airflow pulls in outside air, heats air and blows it through the tumbling load, removes moisture from the load, deposits lint on the lint screen, and exhausts damp air. To ensure good airflow, clean your lint screen before every load by rolling the lint off the screen with your fingers. Do not rinse or wash the screen to remove lint. Warning: fire hazard. Use a heavy metal vent. Do not use a plastic vent. Do not use a metal foil vent. Failure to follow these instructions can result in death or fire. Fully extend and follow the instructions of the dryer vent tag attached to your machine to ensure the minimum dryer distance from the wall. The excessive flexibility of foil and plastic vent material slows air movement, traps lint, and can be easily crushed. Replace plastic or metal foil vent material with heavy, rigid vent material that is 4 inches in diameter. Remove lint and debris from the exhaust hood. Remove lint from the entire length of the vent system at least every 2 years. Because dryers are limited in the distance they can move or blow air, be sure your system uses the shortest length of vent possible. Refer to the Use and Care Guide to determine the recommended vent length based on your model and installation.
Okay, I wanted to stop this video here because
Use no more than
I got a lot of responses from people saying that the problem with the thermal fuse going bad was that it was a dryer vent problem. And believe it or not, that's what I thought. When I first went out there, I checked the hose behind the dryer. There was plenty of room. I mean, there must have been 3 feet on either side of the dryer. The hose ran maybe about 8 feet long and went to a pipe right out the wall on the side of the machine. So I checked the hose, didn't seem to be kinked, connected everything back up, and blew the fuse again. So then I went outside, and where the vent is on the wall, I noticed that the there was about 4 or 5 bags of dirt, plastic bags of dirt, stacked up right underneath the vent coming out of the wall. And said, oh, well, maybe the bags were blocking the airflow. And I moved the bags, and it blew the fuse again. This is when I said, wait a minute. This cannot be airflow. So let's take a look at this, and let's take a look at the back of the dryer. And let's identify 4 key components here. Okay, the first component is going to be my thermal fuse itself. And I'm going to go ahead and put an arrow right here. That is our thermal fuse. That is the same as this one right here. And that's the one that is blowing, because that's the one that's controlling the motor. But it's important. I don't know if you can see it too well. Let me see if I can expand my image a little bit. But if you look, this thermal fuse says 196 degrees. That means the airflow coming out of the dryer right here at the vent has to exceed 196 degrees Fahrenheit. That's when this piece will fail. So then we got to look at what's right next to this piece. And right next to this piece we have the operating thermostat. The operating thermostat is right here. Now that is located here on the dryer diagram. Notice the temperature of the operating thermostat is between 150 and 155 degrees. So this piece here is supposed to sense the temperature of the air coming out of the dryer, and that'll be here. I wonder if I can rotate this. It doesn't give me a way to rotate it. So that's no good. Oh, look at that. I just learned something. Hold on a second, guys. I think I can do what I want to do now. So if I go down with my arrow, I think I can draw an arrow going down. No, I can't do it. So anyways, the air comes out of this vent here. The air coming out of here is controlled by this operating thermostat. As the airflow comes out here and reaches about 150 degrees maximum, it shuts the heater off, which is way over here. This is our heater housing right here, and the heater is the bottom half of this unit. So that's what controls the temperature. That's what turns it on and off, and that's what the customer selects. But we have some other safety devices. We have another one right here, and that is our high limit thermostat right here. That one, if you notice, is at 250 degrees. That's located right on the heating element, and it's meant to blow the fuse just in case well, not blow the fuse, but turn off the heater in case the temperature exceeds 250. Then we have the final piece, which is right here, and that's our thermal cutoff, which is 325 degrees. Now, I showed you a video of air circulation. Let's talk about how air circulates, and then talk about the purpose of each one of these parts. The first thing that happens is that air is going to come in the dryer over the heating element here. Now the fan is located behind here, and I'll show you a picture in a minute. So this is called negative draft. Instead of the fan blowing onto the heater, it's pulling the air over the heater. It flows through here and goes through openings on the other side into the drum where the bulkhead is. Now that would be, if I go back to this video for a second, that's this opening that you see right here with this blue arrow. This is the other side of this heating element that we don't see. It's right there. After it flows around with the clothes, then it goes out the dryer lint chute, and that is right here, the openings that we see right here. The air comes into the drum, goes over the clothes, and goes out through there. Now that is also located on this bulkhead right here, and it comes into here. Your filters run down this chute here, and then the fan pushes the air out. Now, let's just say your filter was clogged. The fan's not going to be able to pull any air in. So how are these two devices here ever going to see what's going on the heater side? We're not pulling any of the heat over to this side, so these two devices cannot work. Now, going to, if you said it's a clogged vent, if the hose on the back of the dryer is blocked, if I completely block this opening, yeah, the fan will run, but it's not pulling in air over the heater. This will cause this whole heater housing to excessively overheat. First thing that's supposed to happen is this high limit thermostat, that's this one right here. When it senses there's no airflow, that whole heater box gets so hot at 250 degrees, it's going to shut the heater off, and it's going to try to prevent a fire. Now, if this one fails to control the heater, then we have our thermal cutoff, and the thermal cutoff is at 325 here, and if this piece fails to turn off the heater, or if our heater is grounded, and I'll explain to you about that later, this cutout will shut off to prevent a fire in case these components fail to turn the heater on and off. These devices on the other side here, they're not seeing the heat that's going on there because your vent is either blocked here or blocked coming out. You're not pulling the air you need to pull across these two devices. Now, how do these work? Well, if you've got proper airflow running all over the dryer, and I'm going to clean up some of these lines for a second. If you've got proper airflow running over the dryer, then it's going to sense the temperature of the air coming out the vent, and the operating thermostat, which is located right here, is about 150 to 160 degrees. This is supposed to open and turn the heater off. Now, if the vent's blocked, it can't do that. Now, what if the thermostat, by mistake, can't open, can't turn the heater off? Well, the temperature coming out the dryer is going to keep getting hotter throughout the whole box, but when it reaches to 196 degrees, this thermal fuse will fail. And at 196 degrees, it's still lower than this 250, and it's still lower than this 325 here. So these components don't come into play if our operating thermostat fails to cycle the element. So let's take a look. Here's a picture a guy has on the website where the blower fan is open, and you can see here where the air comes in through the lint filter, the blower circulates it and comes out the dryer here. Okay, if this is blocked, if I completely block this, there's no way that air can get to these components, and that's where the thermal cutoff here and the high limit thermostat will come into play. Now, if you find a bad thermal cutoff, this one here, you will get a package that also has the high limit thermostat with it. It's recommended that you replace both of those at the same time. Now, how would you test my operating thermostat? Well, we're going to go to the back of the dryer, and the first thing you want to do is you want to put a thermometer here, and you want to check the airflow coming out to make sure it doesn't exceed the operating thermostat temperature of 150, 160 degrees. So what do we do to prevent damaging my another thermal fuse here? I'm just going to take a jumper wire and connect these two blue wires together, and I'm going to see if the temperature coming out of here is within my 150 to 160 degrees. Now, some heats may be in 140 or whatever, but just as long as you don't reach over 160, 165 degrees while this machine is running. So let's say it is going higher than 160. Let's say it's hitting 180, 200. Okay, now it's hot enough to blow the thermal fuse, but still we haven't figured out how do we test the operating thermostat. So what you do is you take your voltmeter and put it on voltage 240, and you put 1 meter lead on the red wire here and 1 meter lead on the red wire there. Now that would be, if we go back to the schematic here, you're going to be putting 1 meter lead on the operating thermostat here, which is a red and white wire, and another meter lead on the other side of this thermostat here. Now remember, we have this piece here jumped out with a wire so that the motor will run once the temperature gets hotter than 160, 200 degrees. So when this thermostat is closed and the dryer's running and everything here is good and the heater's on, your voltmeter will show 0 volts. And I'm going to write this down. 0 volts when it's running and heating. So that would be thermostat closed. It's hard to write here. I don't have my fancy little pen. Thermostat closed. And that's okay. But once this temperature reaches above 150 to 155 degrees, this thermostat should open. And if that's the case, then you got 240 volts. Now, if we are still exceeding this temperature and we see 240 volts here, we probably have a grounded heater, and I'll show you what that looks like in a minute. But the case was with me is that this thermostat was not cycling, and when it doesn't cycle, we exceed this temperature here. The point is just because a fuse failed, replacing the fuse and getting the machine working does not mean you fix the problem within the machine. You need to find out, why did it go bad? And I made that mistake. I went into the customer's house and thinking, oh, I got thermal fuse. I had it in my pocket every time I walked in their house. But that doesn't mean I fixed the problem. That only got the machine running. I never took the time to test to see, if this was cycling or not. Now, if you got 240 here and you're still climbing up in temperature, the only thing that could happen is the heater could be grounded. So let's take a look at this picture here. Here's a heating element. Now, the heating element, they redesigned these, I don't know, back in the 90s, late 90s, they redesigned this heating element, and it used to be a lot longer. And they changed the short one to make it easier to replace, but it's hard to see right here. There's rows on the front and there's rows on the back, but right here, this top piece goes across the top of this metal divider here to feed the other half of the element. So power comes in through this wire, goes through this element like this, and then here it jumps to the other side of the element, and then it comes back out another wire on the bottom. But where it crosses here, if there's not enough airflow, this element will sag and touch the metal housing and ground out. And you would think, oh, well, that would blow a circuit breaker if it shorted out. Now if you cut the heater right in half, normally the heater runs off of 240 volts. And if you cut half of it and put it to ground and neutral, the same thing, you put 120 to both sides. So if a thermostat does open, what it does is it turns off half of the heater, but the other half of the heater is still running without any temperature control. And that's where our thermal fuse came into play, and our thermal fuse shut the unit off. So bottom line, the answer is not so much that it's an airflow problem as it is the operating thermostat was not controlling the temperature. So I hope you guys enjoyed it. If you have any questions, put it in the comment of the video and I'll try to respond. And I'll put up another question Monday or Tuesday. Let's see if you can get the next one. Thank you all. Have a great day.